Hello and welcome back. So we are now looking to the third week for this ACW180. Before we move into any part of this chapter on the input and output devices, let us do a little bit of a recap. So what we have been discussing from last week and the week before actually we just talked about the general on in terms of how accountants is benefiting from the information technology and information technology itself. In the last week lecture, we actually look into what is the parts of a computer that actually helps in terms of computing the in terms of computing, right? What types of components inside a computer, and from there onwards we actually look into those components in details, right? We look at the first one is the CPU, the second one is the memory, which is the RAM, and the third one is on the storage. Yeah, of course we talk about the ROM as well, but these are the main highlights that I want to go through with you. So let us move into the CPU. As you know that in computing, a computer calculate differently. They calculate using the binary system. The reason being binary is because of how we can control the input of the electric, which is 1 and 0. When there's a current, it became 1, and when there's no current, it became 0. And multiples or different types of logic gates, yeah, would actually combine, and they became these not multiples, billions of these logic gates being combined, forming the transistor forming the IC, the integrated circuit. And in so, right, it actually form up the CPU. CPU is the brain. Right, it is the brain of the computer, right? Of the computer is the brain. And that's like a very basic or a very vague introduction on how the computer computes. And then in terms of the brain of the computer is the CPU. And I like to again recap and highlight on how this CPU instruct, right? The instruction cycle. Instruction cycle over here is very important. It starts with the F, D, E, S. First it fetch F, E, T, C, H, then it decodes, then execute, and finally it stores. So RAM and storage is here because of this instruction cycle. Alright, I want to highlight on this. So usually the processor, alright, we actually talked about the component inside this CPU. But let us not go into the complex part. Just look into this fetch over here. Usually the processor will retrieve information from the memory which is mainly from the RAM, right? The random access memory. It will fetch the instructions, or it will fetch whatever kind of input first, right? It will fetch from the RAM, then it will go and decode. All right, very simple. Is like any input. Remember the truth gate on the logic gates, so there's like certain code you send inside. Later we'll look at the input device, right? We'll send in the input process by the system, it goes through, and from there onwards the CPU will then decode. It will decode, or it will decipher what action is required. Basically it will compute lah. Alright, if you compute, go through certain sequence, it will think, and then finally it will execute, which is the instruction is being carried out, often involving the algorithm or logic operations or moving the data. Alright, then finally if there is a result, usually it will just be written back to the memory or the storage. Alright, so it goes like this. Alright, RAM inputs some instruction, then the CPU will start to think, then it will execute, you can see that, and then it will goes back to the RAM, or it will store inside the storage. A very simple example is this complication, right? This is the keyboard, right? So when we hit the A, button from the keyboard, it will go inside to the computer and it will process, it will think, and then it will execute, and it will store either into the storage or it will be random. All right, pretty much that's it for me to highlight on. Alright, of course we have from here we can say that the RAM actually changes from different grade, from different speed, goes up faster. All of this right? So as time goes see increase. All right, so CPU, better CPU, we talk about it process faster, it goes through multiple layers, that it can think faster, multiple core, right? Multiple core. And then the RAM, we can say that they can process the informations, not really process, right? It will have a faster speed of reacting back to the whatever resource we want to use. And then the storage will read and write the data that we want to input into the system faster as time goes on. We can say that last time that hard disk, right? Hard disk then goes up to the solid state drive, and then there's the more latest one which incorporate a faster speed. That's it actually. So over here I like to prompt one thing that I actually left out is accountant, right? Accountant over here. Why, right? Why is having better efficient or why is efficient hardware configuration matters, right, to the accountants? Well, if you talk about you want to do graphic design or you want to do programming or even gaming, then a faster computer speed is better, right? But how about the accountants? Why is it a concern for us, right? Over here I have four reasons, right? Four reasons of why the tech efficiency matters to us. First of all, it is very obvious that we would want to have the speed in processing the transactions, so or in executing the work. So you don't want to have a computer that start up so slow, and by the end of the day you need to by the end of the day you actually consume more time booting up the computer than doing your actual data transaction processing, right? So you want those hardware to be efficient so that you can process the transactions or data faster. Then we can see over here, number two is over here actually it's supposed to be like this, all right? Accurate and reliable. You want the more efficient data so that it will be accurate and reliable in terms of it doesn't break down, right? So here put doesn't break down. So you want to have efficient hardware configuration to ensure that your computer doesn't simply break down anytime. If your computer actually broke down while you were doing your transaction processing or in the midst of your business, you're gonna suffer a lot of issues, right? And that would be it would cause a loss. You need to redo everything, double work. Sometimes it might even compromise your businesses, where the data or the informations of your customer or supplier lost, then you cannot collect back your debts anymore. Just saying, right? If it's a big business, you will not keep track of every single one of your debtors or creditors. So we want to ensure that a better system will not break down easily. We have the third point over here. We look at multitasking, right? You want a smooth multitasking. So again, why? It's because you want to have a smooth multitasking so that you can do the presentation of data at the same time. Maybe you can do transaction processing. All right, I don't know, multiple work. You can basically handles, all right, can basically handles more complex or more sophisticated software to do a more complex data analysis. All right, and finally before I end the recap, is you want to have you want to have an efficient hardware configuration to ensure that in the future, all right, in the future you have the scalability. All right, the scalability, so that more efficient means that if you have more efficient now, you don't have to spend more money next time to upgrade your software, right, hardware. You don't have to upgrade your hardware. You don't have to have a better CPU or better RAM or better storage, right, or larger storage. Okay, so so the configuration does matter to us as accountants. We want to make sure that we have the idea on how this thing works, how the components works, and then to ensure the most, what I would say over here, the keyword is optimal. All right, optimal hardware for us accountants to actually carry out our task, right? To carry out our task. So that's it. Pretty much this is the recap. Next we'll go into the chapter. All right, I'm gonna stop this first. See.